All right, so we've added some labels to our visualization for the title, for the x-axis, for the y-axis, and we're showing this line of cumulative deaths for the whole world. But what I would like to do is split this line into its constituent parts. And doing this, we might need to upgrade to the new data format from Johns Hopkins. Yeah, that's what I want to do. That's what I want to do. See, it's pulling from this old data set. And let's see how we can pull the live data set. Yeah, see, this is essentially what our visualization is pulling for. It's a page that has moved or been renamed. So let's see what happened here. So this is the Johns Hopkins data set. And the time series is what I was interested in. And see, there's a deprecation warning. These files, the ones we were using, will no longer be updated. With the release of the new data structure, we are updating our time series table to reflect these changes. Please reference confirmed global. Yeah, that kind of makes sense. This is a good read. Upcoming changes in time series tables. The upshot is 3 new time series tables will be added for the US. At the county level. This is epic. So I want to make this line chart for all the US counties, but first let's do it for the countries because that's already been done and we sort of know what to expect. The tables will be renamed time series COVID-19 confirmed global at the end. So I think that's all we need to do is update the file name that we're referencing. Let's just take a look at the file itself. It's got the same breakdown it did before, province, state, country, region. But let me see for the US. For the US, it does not have states, I don't think. I'm trying to find US. Where's the entry for US? There it is. Okay, so now this data set has changed. Before, it was all the states had their own entry. Now the US as a whole has one entry in this table. And other places have like a breakdown. And so if we visualize this data directly, which we're going to do first, is then we're going to see a line for Bermuda, a line for Cayman Islands, a line for Gibraltar. But ideally, I would like to just see a line for the United Kingdom. Hey, check this out. There's a summary column for United Kingdom. Oh. So I think we're going to actually need to... One thing we can do to solve this is filter out all the rows that have anything present for the more detailed area. Yeah, I think that's what we're going to need to do. Let's get at the raw URL for this. So if I click raw, I get this URL here, which I'm going to paste in our code. Before I do that, I'm going to fork this just so I don't break this and rename it to pulling live coronavirus data. So in useData.js, we've got these different CSV URLs. The one that's being used right now is for a fixed commit, so I'm going to comment that out and then uncomment the one that we had before for pulling the live data. And I'm going to paste the new URL here. And see, the only difference is in the end of the file name. So I'm just going to paste in this string itself that URL, get rid of that comment, and hopefully it should work. All right, look at that. Great. Aha! It's working. So this is now up to date. This is going up to, well, I wish I could say by looking at it. I don't know exactly. March something, March 20 something. So that's good. That's how we can pull the live data. So I'll fork that as well. Why not? Because now we're going to start working on lines for each country, or how should I put this? Coronavirus deaths over time by country. Yeah, by country. And so we've got the title there at the top. Let me just update that as well. Over time by country. And then we have to go into this data file, this use data thing that we've got. Oh, before we move on, I want to get this URL that will not break that shows us this view that we're looking at right now. So just before we move on, I need to get that sorted out. So I'm going to delete that. Go over to this page here. Go to the latest commit, this one here, and then go to Browse Files, COVID-19 Data, Time Series, Deaths Global, Raw, and this time the URL has a commit in it. And so I can copy this to get this URL that's never going to break. And so if tomorrow I look at this and it's broken, I can just uncomment this line and everything should work. So let me just test that it works now. Okay, it's working now with that commit. And so, in case this breaks, I can resurrect it by uncommenting that. Great. So let's consider that we want one line for each country. The first good place to get to would be just a console.log that prints out all the countries for us. And by the way, here's where we are doing our aggregation. We're just summing up across all the rows, the total. So in the very beginning here, we can say console.log raw data. And this is what we see, this array where there are objects, each of which has values for all these days. And it's got a country/region and a province/state. So what we want to do is filter out all of these that have anything that's not an empty string for province/state. So I'll say const, I'll call it countries data equals raw data dot filter, a function that takes as input D, one of the rows, and we can just return D at province/state. And now we can compare raw data dot length, the length of the original data, to countries data dot length. And we should get two different numbers here. 76. I don't think this is quite right because, okay, this is only including the ones that do have something for province/state. We want the ones that don't have anything. So if I just had an exclamation mark right there to invert that Boolean, now I should get the countries. 173 countries. And just to confirm, I'm going to console.log countries data at index 0, just to see the first one, to see what it is. And it happens to be Afghanistan. That's correct, and there's nothing for province/state. Great, so I'm just going to make a comment here. Filter out rows that represent provinces or states. And now, to do a line chart with multiple lines, we're going to have to come up with a data structure where we have, I think we need an array of arrays. The outer array is the different countries, and the inner array is the time points, the points in time. And exactly how we do this, I'm not sure. I'm just sort of going to go at it and see what it would look like to have multiple lines in our JSX here for line chart. So in the line chart, instead of having a single path, we're going to have many paths. And the way we would do this in JSX is to break out into a JavaScript statement, which, by the way, there's no control flow here, so you can't put if in here, and you can't put like const in here. It just has to be a single JavaScript expression that returns a value. So we can say countries.map. I'm just imagining we have a variable called countries, which is an array. And then we can take each country and map it to, and so I'm defining a function that will return whatever I put in parentheses here. And in these parentheses is where I'm going to put the path. And we have to, instead of passing data, we have to just pass the data for that particular country. And I don't know how we would get at that, but maybe country.data or country.values or something. We just need to map over the country's data. All right, sorry. Let's figure this out. Just to get a sense what we're dealing with, console.log country's data, it's an array where each of the objects represents a single country, but it contains the time series for that country. So we need to take the days like we did before. We isolated the days. This time, for each country, we need to return days.map day blah blah blah. And so what we have to do is say return country's data.map. I'll call the row D, and then I know for sure that we can access D at country/region. So I'll say const country name equals D at country/region. And let me just test that that is working correctly by saying console.log country name. Okay, that seems to have worked. That's great. So we've got all our country names. And what we want to do is return a time series for that country based on the days. And so we can say return days.map. So for each day we need the date just like we had before. But here's where it's a different thing. The death total is, I'm just going to get rid of all that. All we need to do is extract the data value from the row. And so it's going to be D at day, I think. Yeah, that's what I did earlier with the summation. And so if I just use that same logic, and we needed to use unary plus to parse the strings into numbers, I think this should work. And so this is what's returned by transform. And I'm just going to add another comment here that says get time series data for each country. And now, if we say here, console.log data, the test here is did it work? So we get an array where each entry is an array. That's exactly what we needed. Remember what I said in the beginning? We need an array of arrays. And now we've got it. So each of these arrays has a date and a death total. I'm seeing zeros for death total. Oh, there we go. 4. Okay, the date is good, it looks like. So now we can actually render the lines. And I'm noticing that we're not using country name, which feels kind of weird. Like I feel like we should be using it, but I'll just comment that out for now and see if we need it later. But now we can render multiple lines. Let's try it. I'm going to uncomment what I've got earlier, and countries is actually going to be data, and country I think is accurate. Let me do one thing. I'm going to make sure data is in scope. Yeah, data is getting passed into the line chart. And remember, it was an array of arrays. So I'll call this country data and just pass that into our line generator. And we should have multiple lines. Let's see if it works. No, I'm not seeing anything. We're getting some not a number values. Oh, maybe I didn't initialize the scales correctly. Oh yeah, this is kind of a tricky thing, because now we're going to need to compute the extent over all the values in the nested arrays. Yeah, so instead of computing the extent over data, we want to compute the extent over all those arrays combined. And so let's just combine all those arrays by saying data.reduce. And so my idea here is, okay, data is an array of arrays. We need to get at all the inner arrays combined. So what can we do? We can just take all those inner arrays and combine them, literally concatenate them together. But that's the original data that we had. Trying to think the best approach here. I think the data's in the right shape, and we just need to modify our computation of the scale domains. And so I'm going to say we're going to take the extent of all data, which is something I'm going to define to have all the time series concatenated together. And we use that to compute the domain of the x scale and also the domain of the y scale. And so all data is going to be data.reduce. And I like to use this method of concatenating things or building up objects because it's a clean, functional way to do it. And let me just look up the documentation real quick for reduce on MDN. So array.reduce takes a reducer and an initial value for the accumulator, and then the reducer function takes as input the accumulator and the current value. And so that's what I needed to remember. The first argument is the accumulator, which I'm initializing to be this empty array. And then what gets returned, the second argument is the time series for one country. And I think I called that country data down here. Or I'll call it country time series, because I think I actually used the name country data in that other file. So let me just call it country time series. And so what we want to return from here is just the concatenation of these. I just want to concatenate all the time series data together. And so we can return accumulator.concat country time series. So I think that should work. Let's see what all data is. So all data is this array of 11,000 entries, which is sort of what I expected. And each of these entries has a date and death total. So I think we actually computed the right domain and range based on what's showing up here. Okay, so this is good. This is good. We're just not seeing the lines. I'll get rid of this debugging statement. And why are we seeing no lines? We're getting infinity, it looks like. Yeah, this is again a gotcha of the log scale. But we're starting at 1. Let me just see what the log scale domain is. Well, no, I know what it is because we see that the tick marks go up to like 2K. So we are debugging these paths. So let me add some debugging statements into here. I'm going to convert this from an ES6 function that returns something implicitly to explicit return, so I can put the console.log statement. So I'm going to change that ending paren to an ending curly brace, and then explicitly return that. And then we can console.log country time series here, just to make sure it's the right thing all the way inside of here. It looks correct. We got date and death total. What's the problem? It's going to be ultimately calling this line generator, which is going to evaluate x scale of x value of d for one of these. So let me just see if that works. So country time series, let's just look at the first one, because that would be the equivalent of d. Let's see, does this work? X scale of x value of this object here, we get 0. What about, yeah, that looks correct. What about y scale of y value of this? We get infinity. Okay, I've narrowed down the problem a little bit more. Why do we get infinity? I don't know. Well, do we get the right y value, which should be the death total? It's 0. 0. Yeah, so I think with log scales, you just can't pass 0 in. Let me research. Yeah, this is like a weird thing about log scales that I just don't really know how to get around. So I think we can just add some epsilon. Like, let's just add 0.1. It seems silly, but might be the ticket to getting it to work. Oh no, that has to be inside the invocation of y-scale. Okay. So now we get these lines to show up. Or you know what? We should just return 1 because that's where the axis starts. I don't know. This log scale thing is a bit tricky. What if we started at epsilon? Okay, so I'm noticing this one starts at 1. What if I started at 0.1? Just to get the log scale to comply. I don't know. I'll call this epsilon. And then I'll add it here. And we can define epsilon to be, let's try 1. What's wrong? Oh, it's typo. So if I spell this correctly. Okay, this is pretty much working. Yeah, this is great. This is great. We have a lot more work to do, but at least we got all the countries on here. And, you know, we could make the lines different colors. I kind of want to see different colors on here, but we're not going to have enough colors to use. I don't know, but this is kind of a good starting point, I think. Yeah. Yeah, this is pretty cool. So what I want to know when I look at this is, what is this country out in front? Like, who is that? And what are these other lines? We need to add labels here, and or some way of interacting. One way of doing this that I can see is just adding labels over here. See, there's actually little gaps between these lines. And we could fill in labels, at least for the top ones. These ones would get too crowded, but you know, if we have enough space, we could add labels right along the right. And then maybe like hovering them could make them highlight or something like that. But
hey, Grant, here's something. You mentioned something about colors. How you think you'd run out of colors?
yeah.
Whenever there's something that for each line you would just use something to just randomly generate a hex value and use that as the color, and you would have that color correspond to a legend elsewhere on the page. Millions of combinations of that, you definitely not run out of colors.
Well, the thing about colors in visualization is, even though you might have two different hex values, you might not be able to tell them apart because some of the colors are so close together. But just
two slightly different shades of pink.
Yeah, exactly. And I think a good rule of thumb is like the number of colors, the max number of colors that you can perceive is like around 12, I think. So, but let me just try something experimental. I'm just going to make all the lines random different colors as you suggest. So if I say the fill on this is a string that says RGB, let me just put in some values to get it started. Oh, it's not working because, oh, this needs to be stroke. That's how you set line color. Why is this not... why is this not working? It should at least be... If I say stroke is red, they should turn red. What? Oh, is it being overridden by my CSS? I think it is. Yeah, CSS takes precedence oddly enough. So if I get rid of the stroke definition here, now it works. Okay. So what I was going to do is make these all random colors, which I think would be fun and cool. So I'm going to break into an ES6 string template literal, say RGB, and I want to make these random values for red, green, and blue. And the way we can do that is say math.random, which gives us a number between 0 and 1, so we can multiply that by 255, because the range of RGB goes from 0 to 255. And then I can just, copy this for red, green, and blue. Green and blue, and we have to put curly braces around this whole thing. And looks like there might be some problem, like a syntax error. What is it? I don't know. Let me do this more cleanly. Make a variable, make it RGB of, I'm going to say R, G, and B. And then R is going to be math.random times 255. Okay, now everything's correctly formatted, and we can say G and B like that. And then the stroke on here is stroke color. Okay, yeah, we get different colored lines. See that? So that's what happens when you use random hex values, random RGB combinations. Pretty cool.
Nice, but you're all right. It would be kind of difficult to distinguish.
There seems to be, for example, a lot of overlapping greens. Like, if you had to distinguish between this green here and this green over here, you'd be hard-pressed.
Mm-hmm.
But it's a cool idea, and yeah, definitely worth looking into. But just to recap where we're headed, this one by John Byrne Murdoch uses color, actually. Yeah, interestingly, he does use color here, but I think it sort of has a different meaning, because look at this. Japan and South Korea are the same color. Maybe it's grouped by region, see that? And France and Spain are both blue. That's a cool idea. It's a cool idea.
Yeah, and also might just be similar rates.
Yeah. But one criticism I have for this visualization is that it should include a color legend. It's missing a color legend. Maybe somewhere in the article they say what color is. But if I search for color on the page, I don't see anything. John Byrne Murdoch, if you can hear me, put a color legend, man. Don't know what the color means. He's doing some amazing work on this. Amazing work. This is some cool idea, actually. Okay, everyone. I'll be back